flowing through the network. I'm just telling you what message or what protocol both sides understand. So what does it mean now that we've talked about protocols and where things run? What this means is that the HTTP protocol implementation, that code, is running at layer 7 at the two-end hosts. At the applications, you're running code that implements the HTTP protocol. What that means is it knows how to create HTTP messages with the right format, it knows how to receive an HTTP message and parse it correctly, and so on. Beneath that, we have TCP byte streams. Don't worry about what the term byte streams means. It's just, we'll get to it much later in the semester. It's just how TCP, the terminology we use for how TCP thinks of data. Okay. So a TCP byte stream, again, this means you have the TCP implementation that's running in your OS at both end hosts are exchanging TCP byte streams. When we get to IP, we have this IP, the code that understands how to process IP packets, running both at the end host in your OS and in the switches and routers. So now when we talk about peers that speak the same language, notice it's going not just between the end hosts, but also in the switches. And the same with Ethernet until finally, and then the same with Ethernet. And then below that, we're going to actually put bits out on the wire. Again, so far I'm talking about logical communication, what both sides understand. What would you do if I said that actually that link was a optical transport link? So it's an optical link, OTN. What would you change in this picture in terms of what protocols are running well? Yep. You're right. You wouldn't have to change anything at the IP layer or the TCP layer or the HTTP layer. What about at the Ethernet layer between those two routers? So I told you Ethernet, I can't have an Ethernet sender talking to an OTN receiver, and Ethernet doesn't understand OTN. What would I do? Yep. Yep. Exactly. So the routers would implement both. And this is where it starts to be crucial that you can have multiple data protocol implementations at the same layer running together on the same device even. Right. So here you would be running the OTN protocol implementation at those two routers. And those are the implementations that would put packets out onto that optical link. You would also be running the Ethernet protocol because they have to know how to speak to the Ethernet links that are used to connect to the two end hosts. So we're running both protocol implementations. Any questions? Yep. Within a router, yes. If you had a router, not all routers do this, but certain routers at borders will do this, where they speak they have a particular type of interface on one side and a particular type on the other side, yeah. Yeah? Yeah, hold on to that question. We're going to get to it. I haven't told you exactly how a message flows through this yet. I've just told you what the two peers at a particular layer have to understand, not how to make that work. So just to get to exactly that question, and this should become clearer, but I'll stop again and ask you if it is clearer. I want to recap how we talked about physical communication. So far what we've talked about is logical communication, right? Peers are exchanging messages that both sides understand. I haven't told you how those messages actually get there. That's the actual physical path that a message is going to take. So we're going to do that now. I wanted to bring you back to that analogy we had again with the CEO and the two CEOs talking, where we said you start with this letter travels down the layers, so kind of down the stack, then across the world, and then back up the stack. Okay, that was the path of the letter. And so we'd said that communication goes down to the physical network, that was the FedEx infrastructure in that example, and then goes back up to the relevant layer. So now, looking at that in the context of our layers, what that means is that this red line here is the physical path the message is going to take. It's going to start at the application on one side, go down the stack, get out onto the wire, go to that router, go back up to the IP layer, again down, go out the next wire, up, down, next wire, and then up the end host. I'm now going to make this a little bit more complicated, but now you'll hopefully start to understand exactly how a message flows. Let's try to blow that up a little bit more. So far we've been talking about that logical communication between peers. What does that mean? So here I'm going to start using these dashed lines to represent logical communication and solid lines to represent physical communication. Right. So we said we have these HTTP protocol implementations running at both end hosts. Right. So you have some application level message to send. We also said HTTP builds on top of the TCP implementation or the layer 4 implementation at that system, right? So the HTTP code up there is going to have a message. It's going to hand it to the TCP code. Just pass the message down or invoke the interface of the TCP code at that end host to the left. Okay. Same thing, passing it down to IP. Right? That IP logically is speaking to the IP layer in the other routers and switches. But physically, what that IP layer is going to do is it's going to send the message down to the data link layer implementation. In our case, that's Ethernet that's running at that end host. Okay? And then that Ethernet interface actually finally is the thing that puts bits out onto the wire. So part of a message through this diagram looks like this. Where I started at the application level, I kept passing the message down the stack, then the message was transmitted over a wire, and then it went back up the stack. The important thing to notice here is what's going on in this router, right? Where the message came in on the Ethernet interface. Remember I told you Ethernet does not know how to talk to OTN, and it doesn't have to with the way we've wired these modules, right? Ethernet just passes the packet up to IP. And then what does that IP module do? It'll do something like it'll look at the destination address and say, if you remember that forwarding table, it'll say, my next hop in this path is to go out over this OTN wire. And that's why it hands it down to the OTN interface at the data link layer. Okay, so there's no violation of layering here. We don't have two protocols that don't understand each other speaking to each other. Does that make sense? Yep. Right, so the HTTP message that's at the end host to the left is effectively sending an HTTP message to that message to the HTTP implementation on the right, the end host. At the end of the day, that's what we're trying to achieve. But in order to get there, it's not like HTTP doesn't have a wire to HTTP. It has to go over that physical network at some point. And the way it's going to do this is by passing it down these layers. And I'm going to get to this in a bit, but each layer is going to add some information that helps the next layer down forward that packet on. Yep? The OTN interface in this example is required because I have an OTN link between those two routers. Thanks for raising that. I should have made that clear. The only reason I need that OTN interface at the data link layer there is because I have an OTN link. If I had a wireless link, I would have needed the Wi-Fi protocol implementation. Right? Yep.
You're using the same framework between the two routers too. You still need to go to the IP layer and come back to transporting layer.
Right. So the question here is, why did I have to go up to the IP layer? And thank you, that's the crucial part in this picture, so it's good to get it right. The reason I had to go up to the IP layer is, think about it, what if I did not have the IP layer? Right, and I wanted to send the message directly from Ethernet to OTN. In order to make that work, Ethernet would have to know what format or what interface OTN supports. And so every link technology in the world would have to know how to convert between all possible link technologies. Ethernet would have to know how to send a message to OTN. OTN would have to know how to receive a message from Ethernet, and so on. Instead of which, what we're saying is the only thing that you need to know how to, if you're link technology, if you're Ethernet or OTN, the only thing you have to know how to do is hand a packet up to the IP layer and accept a packet from IP. As long as we all know how to interface to IP, this can work. Yeah. That's a great. What if that middle link was Ethernet? Then you wouldn't have to go through IP. That's absolutely correct because you understand what's on the other end. You had a follow-up question, or that, say the same question? Okay. Other question? Yep. Locally, as in to a host. What would local? Two end hosts connected to the same router. Again, it depends on what the interface at the other end host was. So if I got rid of the second router, but I said the link between it, the first router and the last host was OTN, I would still need to do the conversion. If it was Ethernet, I wouldn't have to go up to the IP layer. Yeah. You could have. So the question is, why is it an OTN interface? Could it have been an Ethernet interface? Typically, different links have different characteristics. So for example, a Wi-Fi link is much lower bandwidth. An OTN link can be 100 terabits per second. So the assumption in this example is the operator had a reason for putting a high bandwidth, low delay optical link in there. So that's kind of an assumption going into this picture. Yeah. Yes. So the question again is, if that middle link was not an OTN link, was an Ethernet link, would I have needed to go up to IP? The answer is no, because Ethernet would have known how to pass it between Ethernet. And I'm going to get to that explicitly in a few slides. But yeah.
So you said we don't need to like transfer to the IP for Ethernet, but like how does the interface know the next layer is using Ethernet or OTN or any other way?
Right. So this is jumping ahead to many lectures, which is how would Ethernet have done it? So within a link technology, Ethernet has its own addressing scheme and runs its own routing protocol. And so when you received the packet, you would have said, what is the Ethernet destination, and do I know how to forward it? Right. But in this case, there was no Ethernet destination. You had reached the destination. You were done with Ethernet, so you hand it up to IP. If that didn't make complete sense, this should make sense when we talk about Ethernet later. Yep. Yeah. Right. So from the point of view of this Ethernet interface here, you received a packet, you're done. And when you're done, what do? You take out the Ethernet header, which we're going to the next slides now, and you send it up the stack, which in this case is IP. So in the very first lecture, we said that the job of the internet is to interconnect networks, right? That it's a network of networks. This implementation here is exactly what makes that work. The fact that you have IP there, if you look at the role of what IP is doing in this picture, it's interconnecting different link or different network technologies. And as long as we speak IP, then we know how to jump between this Ethernet and OTN network. There's more. I haven't told you how IP has the information needed to know that it had to go out over that OTN interface. That's going to be the job of routing, but that is exactly the role that IP is playing. Right. So to recap physical communication, are we all good with that previous picture? Yep. Okay. So to recap physical communication, we said communication goes down to the physical layer, across a network, and then up to the relevant layer. Okay, so I've just told you what that physical path is. I haven't told you how each layer knows what to do with the message and where to send it next. In going back to our CEO context, the way each layer knew what to do with the message was through this notion of taking a letter, putting it in an envelope, putting it in a FedEx envelope. And every layer knew how to take something from a layer above it, and then how to put it in a format or in a package such that the next layer knew what to do with it. And similarly, on the receiving side, like the aide knew that when you get the FedEx envelope, you open it up, and you take the envelope, you open it up, and you take the letter to the CEO. Right? So each layer knows how to kind of unpack packaging and repack the message. And we said, so communication goes down to the physical layer network, then up the layers, and at each level we add some packaging. And the lowest layer, so that truck carrying the FedEx envelope, has the most packaging. Right? And the application has the least packaging. It has the original message. We're going to do the same thing on the internet. So at layer 7, the